Could tiny machines one day repair the human body? What if the future of medicine is not bigger machines, larger hospitals, or stronger drugs? What if the next great leap is smaller, so small that it could move through blood vessels, slip through tissues, reach damaged cells, and repair problems at the scale where life actually begins to break? For decades, that idea sounded like science fiction. Tiny machines inside the human body. Microscopic repair crews, medical systems so small and so precise they could work from within instead of attacking disease from the outside. But now something remarkable is happening. The first version of that future may already be taking shape. Not as swarms of silver movie nanobots. Not as futuristic robots with arms and eyes and miniature tools. But as something quieter, stranger, and in some ways even more powerful. Tiny, programmable systems that can carry instructions, target diseased tissue, edit faulty biology, and maybe one day travel through the body with extraordinary precision. Because when most people hear the phrase tiny machines, they imagine metal. But the body does not care whether something looks mechanical. What matters is function. Can it move with purpose? Can it find a target? Can it deliver an effect? Can it respond to conditions inside the body? Can it repair instead of merely overwhelm? And by that standard, medicine has already started entering the age of microscopic machines. One of the clearest signs came when the FDA approved Onpattro, the first siRNA therapy. It uses a lipid nanoparticle, an extremely small delivery vehicle, to carry genetic instructions into the liver and silence a disease-causing protein. That is not a humanoid robot, but it is a tiny engineered system carrying a mission into the body and performing a precise task. Then the frontier moved again. In 2023, the FDA approved Casgevy, the first therapy using CRISPR gene editing. That mattered because it showed medicine crossing another threshold. Not just blocking disease, not just slowing it down, but directly rewriting the biological instructions that helped create the problem in the first place. In another major step, a 2024 New England Journal of Medicine study reported in vivo CRISPR editing for hereditary angioedema, where a single dose produced strong, durable reductions in a key disease driver. Think about what that means. For most of the medical history, treatment has often meant repetition. Another pill, another injection, another round, another cycle of management. But a programmable, microscopic intervention begins to suggest a different model. Find the source, deliver the instruction, change the biology, let the body continue from there. That is not yet the answer to everything, but it is a radically different direction. And then there are the living machines. Some of the most astonishing medical advances do not come from metal or silicon at all, but from engineered cells. CAR-T therapy reprograms a patient's own immune cells so they can identify and destroy specific targets. It first became famous in cancer, but in 2024, the New England Journal of Medicine published a case series showing that CD19 CAR-T therapy produced remissions in patients with severe autoimmune disease. In other words, cells were redesigned, sent back into the body, and used almost like precision-built internal agents. So maybe that is the first great twist in the story. Maybe the earliest tiny machines that repair the human body do not look like machines at all. Maybe some are lipid particles, maybe some are gene editors, maybe some are engineered immune cells. Maybe the boundary between biology and machinery begins to blur until the question is no longer, is it a robot? Maybe the better question is, can it do the work of one? And beyond that threshold lies the version people have imagined for years. True micro-robots. Tiny mobile devices that can be guided through the body, tracked in real time, and used to deliver therapy exactly where it is needed. That field is no longer pure fantasy. Reviews published in 2025 and 2026 describe rapid progress in medical microrobotics, especially in imaging, magnetic control, responsive materials, biosafety, and targeted drug delivery. And in late 2025, Science reported a magnetically guided micro-robotic platform that navigated human vasculature models and large animal systems under clinically relevant conditions. That does not mean your future doctor will release a cloud of nanobots into your bloodstream next year. It does mean the idea has crossed an important line. It is no longer just a cinematic fantasy. It is now an engineering problem. A hard one, yes. A dangerous one, sometimes. A problem still filled with obstacles, but an engineering problem all the same. And the obstacles are real. The human body is not an empty hallway. It is a violent, crowded, dynamic environment. Blood moves fast. Immune defenses attack foreign materials. Tiny devices must be visible enough to track, safe enough to tolerate, controllable enough to guide, and degradable or removable enough not to become a second problem themselves. Medical microrobot researchers now focus heavily on these exact issues: actuation, imaging, navigation, visibility, and biosafety. So no, this is not the part where someone claims that microscopic robots will soon cure every disease on Earth. That is not the truth. The truth is more interesting. The future may arrive in layers. First, smart particles that carry instructions. Then gene editors that rewrite damaged code. Then engineered cells that hunt, destroy, or reset disease pathways. Then microrobots capable of traveling to a location, sensing conditions, and releasing treatment with stunning accuracy. Not one miracle. A staircase, and if that staircase continues to rise, imagine what it could mean. Instead of flooding the entire body with a drug, treatment could be concentrated where it is needed most. Instead of cutting through layers of healthy tissue to reach a target, intervention could arrive from within. Instead of waiting for damage to spread far enough to become obvious, tiny systems might detect and respond earlier, while disease is still local, still quiet, still vulnerable. Cancer, vascular disease, inflammation, clotting, internal bleeding, localized infection, tissue injury. The dream is not just smaller treatment. It is smarter treatment, more local, more adaptive, more precise. And maybe that is the deepest shift of all. For a long time, medicine has often been shaped by scale. Bigger scans, bigger surgical systems, broad-spectrum drugs. Large institutions built to respond after the body has already begun to fail. But the body itself is built from tiny interactions. Molecules, cells, signals, barriers, repairs. If disease begins at small scales, it makes sense that some of the most powerful future treatments will have to meet it there. Not above the problem, inside it, at its level. That is why this idea matters, because tiny machines repairing the human body is not really a story about gadgets. It is a story about precision, about entering the body not as a battlefield to be bombed from a distance, but as a system to be understood, navigated, and repaired with increasing care. And maybe one day, when that future is fully mature, we will look back on this era the way people once looked back on the first crude aircraft. Not as the end of the journey, but as the moment humanity first proved the direction was real. So, could tiny machines one day repair the human body? Yes. In some forms, they already are. In other forms, they are still being built. And in their most advanced form, they remain one of the most difficult and important engineering challenges in medicine. But the path is visible now, and once a path becomes visible, history has a way of moving toward it. The age of microscopic medicine may not begin with a dramatic invasion of science fiction nanobots. It may begin quietly, with particles carrying code, with cells given instructions, with editors rewriting faulty genes, with micro-robots learning, step by step, how to move through the rivers of the body. And if that future arrives, it could change medicine forever. Not by overpowering the human body, but by learning how to repair it from within.